Hi, Leo, founder of Graphistry. I'm going to be talking about AI that investigates and GPU Cypher, and then at the end of it, I'm actually going to be talking about those together. Any work like this is really a team effort, so a lot of our team, and I'm just like a person in the middle here. For folks who are not familiar with us, most who are familiar may know about our core product, the First Visual GPU Graph AI platform. So we'll be talking a little bit about that and some of the new stuff. Graph the Planet also ends up being one of our annual community events where we just kind of share a lot of what's roadmap and things that have been happening with the community. Also for folks online, hopefully that's helpful. And then the first half of the talk, we're really going to be focusing on AI investigations and how that goes together. Likewise, just as background, we have been around for a little while, so we do work with, governments around the world use us, think like NATO, Five Eyes, banks, a lot of regulated industries, but all the way down to like startups, scientists, newspapers. So we get into a lot of interesting investigative scenarios. Generally, we try to give them the power tools, but a lot of the work that we try to also always make sure we're kind of leaning in with some operational teams to actually do some investigations of our own, that just make sure that we're eating our own dog food. Also, history of open source. So even if you haven't heard of us, I'm guessing people here have used a database, which nowadays we use something like Apache Arrow. So we helped start that project, and NVIDIA Rapids for GPU data frames, which we helped start just so that we can actually build Graphistry itself. So kind of kicking it off here, I think, let me see if I can move this, or this is going to be really awkward. Okay, maybe that's, I don't know if that's better.
Move it up to the top, move your mouse.
Yeah. This Zoom does not make it easy. All right. I think this is about as good as we're going to get it. Okay. Let's go back here. Okay. So backpedaling a sec. So I would claim that investigation teams have an intelligent automation problem. I'm going to be talking mostly about security. We happen to do a lot of investigations, other domains as well. But for simplicity, we're just going to focus on cyber. But fraud, IT, supply chain, a lot of the operational teams we work with feel similar. So in cyber, when we get alerts, a few interesting numbers here to get a feel for it. So over half of the breaches, and this is Mandiant's, now that they're acquired by Google, they have their annual report. They report that over half of the breaches are externally reported. That's like a very polite way of saying either the hackers told them that they got in because it's ransomware, or it's somebody else kind of knocked on the door and said, hey, you have a bot on your network attacking me, please stop it. So we clearly, we're in kind of like a right of boom, assume breach scenario. That is reality. It's not like the teams aren't doing anything. So a fifth of the SOC's time will be investigating, like correlating, timelining, like all that kind of stuff, aggregating. And even with all that effort, in reality is the surface is increasing, and then there's always pressure to do more with less, like all the kind of the usual nonsense. And the reality is if you talk to any team, they'll say, yo, half the alerts, I would like to investigate those, but we couldn't, or we can't in time, or even if we can, the reality is they don't feel it's sufficiently investigated. And so that's just reality, right? And so what's interesting from a historical view is like the definition of crazy is doing the same thing and expecting a different result. And so 2 decades later of a lot of, I think, security engineering approaches, unsurprisingly, Python automation does help, but it doesn't, help enough. ML detection does help, but it does not help enough. Even AI workflows, like, hey, I have my Python workflow, could it call ChatGPT to classify something? Not enough. And basically, I'm making the argument that from a breadth perspective, these don't cover enough breadth. And for each one of those breadth, it does not go deep enough. And to me, that's basically a failure of intelligence automation. So we're going to be talking a little bit about that. But I'm going to kind of detour a little bit. So obviously, I'll be talking about agents, if you haven't guessed. But I think it's useful to think about the coding world and what's happening there, where basically we could look into the future about 1 or 2 years by understanding what's happening there and reflecting on that. So in the coding world, GPT-4 came out, is pretty awesome. Startup Cursor went from, in record time for any startup, $0 to $100 million. People really like to have code autocomplete. So that's pretty awesome in 1 year. But the next year, Claude Code did something really interesting. The agents were able to code longer, so you can kind of have them do more. And then they went from $0 to $2.5 billion in revenue in 1 year, basically. I might, maybe it's like 1 billion or like, but at that level, this is crazy, right? But I think that's money, but like I think adoption is like, it's clearly something with adoption. And that's when Google and Microsoft said something interesting. Hey, already a fifth to a third of our code is AI authored. And this was last year. This year, we're kind of on track to have a fifth of all open source code on GitHub to be AI authored. And if you kind of like look at the curves, then it means like, okay, so next year, most code in general is going to be AI authored. So clearly the coding community is going way agentic. So I want to kind of ask a few questions here. First is, so obviously if you're in this room, you use ChatGPT in some way, I'm not even going to ask, but who uses 3+ coding agents to write software at the same time? So we've got a few hands here, 1, 2, 3, 4. So like maybe, and it's not a big room, so it's like, reasonable. Now, who uses 3 agents at the same time for investigating event data? We have, oh my gosh. Well, okay, we have one of our staffers, we have somebody building an agent and somebody also building an agent. So basically operationally, nobody. I gave a talk a few months ago, I think a Chaos Congress, think of it like DEF CON in Europe with like more like disco lights or something. And 1,000 people, it was the same thing. Basically, coding agents everyone's doing, they're actually really pushing these, but nobody's investigating with them, like especially at the level that the coders are doing. So clearly there's some sort of gap. Now, Graphistry is a very kind of deep tech, kind of science and engineering driven organization. Like that's why we've been able to do year over year the type of things we do. And a lot of that starts with measurement. And in the age of AI, that's especially true. And so when we're looking at this investigation automation gap, one thing is if you cannot measure it, you cannot improve it. So that's Lord Kelvin. That's kind of a normal engineering thing. But then as a community, when we have in a day when it's easy to vibe code anything and just open source anything, we're getting a lot of basically a kind of freeze and puppy, where it's like, oh, somebody made a thing, but it's almost like an art project, because if you actually adopted it, now you have to actually ensure quality, right? Because they're not doing the evals, right? So it's almost like negative value. So I think it's part of important is measurement is actually setting North Stars of what is good. And then if someone's going to release something and they can't say that it's actually hitting the public eval, well, it's an art project. It's not a tool anybody honestly should use unless you're investing it as some sort of art project. And then I'm going to say this, I don't know if as a CEO I should be saying it, but increasingly when I look at software, evals, or you could sound it out, that now I'm pretty increasingly, even though I didn't start on this side, I'm actually now feeling very strongly about evals. And so I'm going to kind of give you a bit of feel for it. So about a year ago at RSA, we made an announcement. And as you heard about Boss of the Sock from Dave earlier, this actually made some waves. We have a little URL there. Like if you just search Louis.ai beats Boss of the Sock, we have a cool video. We have a bit of cameo, like a cartoon, like an anime form of one of our folks here who actually might have just given a tutorial you'll enjoy. But the reason that it made so many rounds is because it was a good eval. We intentionally, we do all sorts of benchmarks of our systems. We intentionally picked that one because we're like, hey, what's the most representative one that everybody knows in the community and anyone who kind of has been around and actually tried stuff? And Dave's team did a great job. It's over 100 data sources. It wasn't just like alerts. It's like different, it's logs. It's like Windows logs. It's S3 logs. It's like broken buckets. It's identity data. It's like layers of alerts. They did a really good job. And then anyone who's done a CTF, and thousands of people do it every year, they know that the tasks being done are timelining, scoping, correlating, all these annoying questions that 20% of the time I was talking about. So it was a good one. So the result we released last year was, hey, in these kind of initial attempts, we got a passing score. And that was kind of a shock to a lot of people that whether it's us or the sign of the time, hey, this thing's coming. And in a sense, we actually had numbers where we know that it was literally a 10x, 20 hours becomes 2 hours, 2.5 million minutes to answer one of these kind of real questions. So we've been measuring more, and we're starting to release things. One of the things I thought was interesting, also playing off of Dave's thing, I just launched Bots Bench a few days ago, and we're starting to look at both the agent harness and the model underneath to start saying, hey, which of these, like if you're going to say you're an AI SOC or if you're just a general AI tool good for cyber, and like I think everyone should try to use Claude Code for this kind of stuff. If you're not, like I bet most people already here are. But we're starting to find interesting things. Like one is Claude Code, and it's almost like embarrassing, like humble pie to our team. They actually, Claude Code 4.5 gets that same 73% that we worked so hard on last year, and they actually did it out of the box and with less prompts. And I was like, these are really great. And that one of the things that told me is most AI stock companies probably should not exist because they're not doing as good engineering. Most of them would fail this. Like, if you're an investor on this, make them take bots, I bet most would fail. But the second thing I found interesting, and I was looking at, we do measurement, we're engineers. It was the first time I found model contamination. That the 4.6 series of Opus, like Opus and Sonnet, like you could run the bots challenge, but instead of having the CTF connected to a database and trying to answer the questions, you could just disconnect the database, run it in like a sandbox, and it'll actually start getting a lot of the questions right. And so as a methodology, like we actually have to be very careful how we do measurement, that even getting the evals right are hard. So that's kind of part of why we're running bots bench is not every team could be as serious as us. And that's such a huge misstep methodologically, especially we're meeting a lot of SOC teams that are internally trying to build this stuff, and they're just honestly doing it wrong. So hopefully this is gonna be helpful. So of course, I'm gonna do our new announcement. So the good news is we've gone from a passing score to a 96%. And I'm pretty sure if we wanted to give another month or two, I will probably get 100%. And then instead of 2 or 3 minutes, we now figured out how to do it in about 1 minute per question. That does not mean we have solved investigations. That does not mean we've solved security, I wish. But it does mean like, we're on to the next level of evals, and just as a community, like, it's bots is dead. And if somebody can't beat bots, I think that's a good, kind of tells you where they are. But as a community, that means we do need new benchmarks. So for folks building LLM stuff, or folks actually not building LLM stuff and wanting to get a feel for it, I want to kind of make a few points here. So our score last year and kind of where Claude Code is today, I think that's incredible from a historical perspective. But from an AI perspective and a quality perspective, that's much closer to the beginning than the end. And what I mean by that is, like, let's say in an investigation, 10 things have to go right. Like if you miss any of them, the investigation's wrong. You missed it, like the people are still inside, whatever. So if I have like a faulty coin that kind of does each step, and it's right 70% of the time, which is pretty good. Imagine like GPT-4 or something. Well, if it has to get all 10 of them, do all 10 of the steps, well, it's only going to actually have a 2.8% chance of doing the investigation right. So that's not really trustworthy. But if I improve my coin, I improve my model, I improve my agent, like whatever, and like from 70%, like halfway to 100% is like maybe 85%, and then another halfway, and I'll do another round of effort. Now I'm at 90%. Another round of effort, I'm at 95%. Well, for the actual investigation, I'm still at a 59.9%. And if you go to our RSAC floor, like later today or this week, you're gonna have people saying that they're getting like purely automated investigations, but I bet they're here, right? And like, so I don't know what they're automating, but I don't think they're automating the actual investigation, like from like the numbers view. But if I go from 95 to 98, 98 to 99, 99 to 99.5, 99.5 to 99.9, now I get like a pretty like reliable-ish, it's not even reliable, but reliable-ish shot at actually doing the 10 things in investigations right. So there's actually a couple of like our experience, like feeling these numbers has kind of changed my thinking about where what's the future of like the investigation AI factory. So one thing is, I do like for purely autonomous investigation where we are right now, I think we actually could do a pretty good job if it's a short task. So if I am under that 10 steps or like wherever you are in that, what that means is we actually could do some pretty good work. And a lot of the things are basically like this notion of like blocking and tackling, of like, this like a triage or contextualization. I would not call those investigation. I might call them pre-investigation, but I think that's actually really useful to just get rid of the noise. And so I think that's really valuable. The second thing so for Louis, we talk a lot about vibes investigating as an analog of vibes coding. And if you think about it, like let's say I could do maybe 10 steps if I'm being charitable with one of these autonomous SOCs. Well, if I have a human going left or right, well, then I could go from 10 steps to 100 steps or 100 steps to 1,000 steps, right? Because I could keep guiding them going left or right or both, you know? That means I can actually get that breadth and depth that I was wanting that I just couldn't get with all those AI SOC people. And then now from a methodology and an AI factory perspective, if you recall like the keynote, it's all about the loops and building out those validations and smoothing out those cow paths as you go down, you turn a deer path into a cow path by walking down it. The people to do that, like half of them are the analysts who are looking at the data. And so this is why we're so bullish on making Vibes investigating core part of the SOC flow. So instead of data scientists pretending they can come in and do it all, we're actually trying to get in there and work with them and enable them to kind of smooth out tools for themselves and then bring into the broader flow. Reality, that also helps us do other stuff as well. So it's kind of a two-layer game. But that's also, when I think about feedback loops and what a true AI SOC is, which means feedback loops, it's increasingly how I'm thinking about it. Just as a quick example of what this kind of materializes as. Here I'm taking a little example of a boss of the SOC question, like what is the full user agent string that uploaded the malicious link to OneDrive? So it's a reasonable question. But what's interesting is instead of me trying to answer that question, I could turn that into like a timelining exercise, create a full incident response report, and then turn that into a full visual kill chain. That's what the pre-investigation is now. And then that's what the analyst gets. And now because the analyst is no longer going raw into investigation, they actually have like a mini database of investigation that's pre-investigated. Now it's a much easier problem. And so even before we get into learning loops and things, like this is already things that we can do today. It's just like if you asked me this a year ago, like this would have been crazy. So I have been mentioning the phrase vibes investigating. I think it's useful to understand it in two ways. One is good vibes investigating starts with good vibes coding. So our agent harnesses start by doing what the best coding harnesses do. And the earlier talk about from training models was the same thing. To teach a cyber analyst, you first also teach it math and coding. Same thing at the harness level. We need to let it do all that stuff. It's just basic tools. But then there's things start getting different. So for example, in coding, like you're kind of coding and debugging, but in investigations, we're doing like triaging and correlating and timelining. Like they're just scoping, they're just kind of different. Likewise, we're not trying to search 1,000 files to figure out which one to edit. We're trying to deal with like, I don't know, like 1 million or 100 billion events a day and how to go through all the database tables. It's just like a different problem. It's not like, I wouldn't say it's fundamentally one harder than the other, it's just different. Likewise, this one actually is harder, I would claim. In coding, you get to have specs and unit tests and type checks and whatever. But investigating, your job is to come up with the answer. So you don't know going in, like if it's right or not. You don't really have that like nice little oracle. So other things are, I think some things are the same, some are harder, probably some are easier. Yeah, and so there's like I can talk a lot off of that. But I also want to give a feel for kind of some of the things that we do internally. But it's also directionally what we're trying to figure out how to enable users of our platform and our community, because I think they have to do the same thing. Certain things, because I think certain things the platform do, some of them we have to work with the SOCs implementing it. And keep in mind, it doesn't have to be SOC. It could be like fraud. It could be like IT, like SRE, same thing. So let's say we take any eval to do with any of these things. So we have all these, right? What we'll need to now do is like run the benchmark and see where it goes wrong. And maybe it went wrong because the Python code did something wrong, so we're gonna have logs. And maybe it went wrong because the AI did something, so like the prompt is wrong. So okay, we're gonna have all that telemetry, so we happen to use open telemetry, I'm gonna talk about that in a sec. And then instead of us doing the error analysis, we're gonna have the AI do the error analysis. Then the AI comes up with how to improve, whether it's the prompt or the code or anything else that's going on. And then we loop back until basically we do the hill climb, and then we see, hey, we're whatever the thing we value, it doesn't have to be boss of the SOC. It could be your internal, like whatever type of investigation or case you're trying to do, or we're trying to make a new tool that generalizes, and like all of those. Maybe I'm doing count like CTI or something. So we've been building out Louis so that we can, instead of us doing it, the AI could do that loop, and so we can basically methodically and predictably improve quality. What's a little interesting now is, well, now we have a telemetry stack and we have a telemetry process that whatever thing I want to do, I could actually automatically improve it. And so this is something I'm called, instead of vibe coding, I call it like eval-driven AI coding loops. And I think if you reflect on some of the speakers today, they feel a lot closer to this than what a traditional vibe coder would talk about on on one of those social media sites. Like we're all using evals and using that to guide how we improve things. And I want to give a little, just to like really hammer that home. So skills are taking over how teams and practitioners do this kind of things, where like if you're not familiar with skills, imagine you have like a standard operating procedure that used to be like a wiki page or Confluence page of like, oh, if you have like an identity incident, you know, and it's like in New England, you do it like this, but if it's like in Asia, you do it like that. You have all those wiki pages and just define it. There's an interesting study that said that like, hey, if you ask an AI to generate that kind of corpus, and then have the coding agent or whatever try to use that AI generated skill. And it's very natural. Imagine your cloud code and you're like, hey, I want you to automate the workflow I just did. Please make a skill file so the next time you could use it. It's very normal. They found that generally it either didn't help or did worse. So it's like, oh, that's kind of like, well, does that mean skills don't work? No, it just means writing skills badly doesn't work. And so what we found is that, well, if we do a skill, but we also have an eval, and we're like, hey, this is like, I want to do this kind of investigation, or I want to do this kind of tool use. Cool, here's our eval. Now I could then throw the coding agent to actually loop with our skill file and just iteratively improve it and hill climb. And then we start seeing benefits like, for example, 3.7x more of our cases passed. Or in this case, we're actually teaching, we're finding a lot of our users are now starting to like ask us less questions because they just use Cloud Code to use Graphistry, which has honestly been awesome. They do really cooler things, and we get to have more interesting conversations with them. And so what we found is by doing a better skill file out of the box, it wasn't that great, but by doing the hill climb, it was able to handle 3 or 4 times more cases, like going from a 0 to 1. And then also even if it didn't like solve it, like maybe it was able to solve it without it and find its way, we were able to go about 2 times faster. And so like by doing the hill climbing, it's not just our core code, but I think anybody doing prompts, like whether you're a skill file internally or externally, I think this is pretty important. So it's kind of a direction we're going. So that said, obviously we've been busy. One of the other things I kind of wanted to announce here is we're doing something called Louis Desktop. So hopefully you're getting a sense that we are trying to be the best at something, but weirdly, we're also trying to give it away for free. The idea with Louis Desktop, thank you. And so the idea with Louis Desktop is like, I don't care if you're like an Apple, Windows, Linux, you'll be able to install it, use whatever, run it anywhere, use whatever LLM, and you'll be able to get all this stuff. And we've been focusing a lot on the investigative side, so think Splunk, Databricks, a lot of the Microsoft ecosystem, Cousteau, Sentinel. We actually have some announcements coming with them. So that's all there. And then what our real focus on is like, we need to get people successful. I think making it easier for people to try it and start playing with this stuff, getting vibing, I think that's number one. Another thing that we're trying to do is we actually started doing trainings. And so we have an AI masterclass we started doing. So at Black Hat last year, we actually ran the most popular training at Black Hat of all. And so that was really cool. And just to see all the people like wanting to learn this stuff. And then all of that basically funnels towards our regular product where that's cool that once you start getting comfortable, like, whether as solo in a team, you're playing with it or at home, eventually you say, hey, what if I could share my skill files with my teammates? What if when I have a case, I could actually give them a live link to the case and they could start vibing, we can continue together. So that's basically our kind of enterprise or team server. Obviously the usual like RBAC and that kind of stuff. But hopefully that gives a bit of sense of where we're going and what we've been learning to do.
So the Louis Desktop, is Louis Desktop mainly the loop that you just explained for investigations, or is it generic? I can use any skill and it's basically this eval loop that I can build with it?
Yeah, we're making it to be kind of bad coding agent, but on top of that, a really great investigating agent. That's the heart of it. And so everything you could have done with Cloud Code, just a little bit worse. But then once you want to get investigating, it's better. And then some parts feel the same, like API, like other parts feel different because it's more investigation and data oriented. Yeah, I wrote here, for example, data-centric AI plus UI. Cloud Code is very file and text oriented. We can get back 1 million log lines from Databricks, and that's cool. And then we're not just going to dump it willy-nilly into the LLM. We'll actually intelligently do that. And then we have a really great Vibes UI where instead of just seeing like text in the terminal, you actually see like an interactive table so you can investigate. Actually, I'll get to a demo in a second where you can kind of feel a bit of this stuff. So being a little roundabout here, I guess like I'll tee up the demo. It's not like we're not doing Graphistry stuff. We actually have another cool announcement. So again, a reminder of last year, we've had a problem traditionally with as like the data world and data pipelines and like, data is a team sport. Like, you have the SOC analyst, like the security engineer, you have like the data science, we all have to work together. What we found that when we were trying to deploy the Graphistry GPU stack, like imagine you want to visualize stuff like you saw at the tutorial before, we always had this problem is like somebody might have like Databricks or Splunk, they might do a Jupyter notebook or a dashboard, but to do graph stuff, yeah, we could visualize it or we could do some AI on it, but they had to wrangle it. And then often they're like, well, should I just copy all of my data into like Neo4j? And that was terrible because Databricks is really big and Neo4j is really expensive. So that was kind of, and then now it's this big data engineering project when you just wanted to see your data. So what we realized was, and this is actually honestly, it's like overnight success, years in the making. Like in 2022, I put out a piece with Ben Lorca. We're like, hey, for graphs, we need to separate the compute tier from the storage tier. So use any database you want, Databricks, Snowflake, Splunk, Elastic, all that stuff. You even use a graph database. Maybe like they're awesome too. But for all the compute stuff, let's do that compute tier. Let's do it as a compute engine. Make it easy in Python. If you have a GPU, let's use the GPU. If you don't have a GPU, maybe you can offload to a GPU. But if you don't, or you just want to locally, just run the CPU. But importantly, it's like columnar, so that we can actually do all those optimization tricks. And so now I could do something like here. And actually, this is actually the next announcement. So this is what we did last year. We built like kind of low-level engine, but honestly, we're using that so we could build Graphistry. And so like all the cool stuff you were saying. But then we're like, well, what if like could people write it? So how would we have other people using it? And then second is like, could we actually have the AI write it? Like, and what would make that work better? What would be a good like language for AI to kind of do graph data science? And so we're like, well, Cypher is the most popular graph property language in the world. What if we made that run in the compute tier and made that run on the GPU? And so here we have basically, we've already implemented over half of the conformant Cypher standard. It's actually, we found that Cypher honestly is a little awkward sometimes. And so here we have a picture of like a full graph pipeline. There's like a Jupyter notebook. And honestly, this is all open source, by the way. So you can just run this like, just for fun on CPU and it's fine. So we did a regular like data pipeline of like, hey, could I load some tabular data? Could I shape it into a graph? Can I do some graph mining, some graph search, maybe some algorithmic enrichment? Like if you're going to do an ML pipeline, that's what you would probably do and go back to tabular land. Let's do the full graph pipeline. We could do Cypher when we want. Sometimes if your entire world is like selling a Cypher database, you might make certain trade-offs and things get a little awkward when you have to do other things. We don't have to do those things. We could do a lot of flexibility of the compute tier. Our code ends up being actually simpler. And what's interesting, it's also a heck of a lot faster. So for like a 2 million edge graph, which honestly is kind of small from like a performance view, we were processing in about 0.4 seconds through this full multi-phase pipeline. Neo4j took 22 seconds. When we 10x'd it to 30 million edges, now, okay, great, we take 7 seconds. Neo4j just like times out. And that includes their compute tier GDS stuff. So we're about, I think, if you do this out, I think it's about 50x faster. So that was, and this is just free out of the box, again, open source. But again, remember, I was saying something about AI, right? Oh, sorry, yeah, one more thing. Again, this is actually a result from last year. We still need to do new numbers, but basically on just the core engine, we were able to do 1 or 2 billion edges per second on a single GPU. So depends on the GPU size. We can also do maybe 100 million if you have like a cheapo one that costs amount of coffee. But again, like it isn't just about speed, but it's like cost. Like you don't have to have a big footprint. We could do a lot and keep it interactive. So I wanted to go back to the AI thing. So LLMs love language, right? And so now we have a language to talk about graphs, and we have the whole Graphistry ecosystem of visualization, shaping, analytics, all that fun stuff. And so what I want to show demo here is, I gave a talk at AI Village a few years ago during COVID, and we were doing some OSINT analysis with a little bit of machine learning, and I wanted to show taking that full pipeline and now doing it hands-free. So we're going to start on the Louis side. Let's see, does this load? Maybe. OK, cool. We'll give this a second here. So we just jump into Louis. OK, thanks. So I say, hey, get 1,000 profiles from the misinformation data set, Project Domino, and then draw UMAP clustering. So I want to know which accounts are similar. And so and then in the background, the data is connected to Databricks, Splunk, some graph databases, so all sorts of databases. I actually wrote a skill file ahead of time just because I want the demo to run a bit faster, so representative of what a user might do. And so here what we're seeing, an explanation as it runs. So it's different from ChatGPT because you actually get explanations you could drill into. So we're seeing it does its pipeline, it figures out where to pull the data. We can inspect the data. Again, this is where we're data-oriented rather than being text-oriented. So I actually get all these pulled query results, and I have this trail. And then it generated the UMAP. And now this basically recreates half of that entire talk I gave at DEF CON, except for I didn't have to write code. I just wrote a one-sentence prompt. So that part is actually that's already Louis. There's nothing special. This next one is actually something, this is more prototype, so this is not yet in Graphistry, but this is where we actually prototyped it years ago, but we didn't think AI was ready yet, but now we do. So I asked, hey, Louis, can you take that graph from before, but make it a more compact layout? So I wanted to have a prettier picture. Cool, so those 5,000 nodes, 100,000 edges, cool, it laid it out for me. And then I asked, show me the distribution of QAnon users using a purple gradient. So now I'm we get a lot of complaints from users that there's so many features in Graphistry, I don't know how to use it. But now you just tell it what you want and then it'll kind of do it. And so here we have all the QAnon accounts getting highlighted, and whenever through the UMAP algorithm they're similar to other ones, we kind of see that network. So next one I asked, the distribution, what are we asking? Show me the most influential accounts and their connections. So now this is starting to get a little more interesting. And what I want to note here in this one is this is now no longer directly calling the Graphistry API, but now we're actually going to be generating Cypher and GFQL because this is now a more complicated flow. But you don't have to know Cypher and you don't have to know any of these things. And so it creates something called collections, which are basically Cypher statements, and it does things with them like coloring. And so here in red we see the influential ones, and orange the stuff one step out. I could drill into this Cypher, but I don't have to. And then kind of finishing it off, I say, I think, what are the main communities? I didn't see the last one, but what are the main communities in the graph, and explain each one. So often that's actually the job of the analyst. It's once we have the clustering is to kind of go through and hey, what's going on in this campaign or not, whether it's cyber or fraud, you basically have to explain each one. That's your job, is to make sure everything is kosher in each one, and if not, raise it. I just showed the AI doing all of that with just talking to it. So again, the first half is basically Louis desktop. The second one, I don't know, it's wait a few months or wait 6 months, whatever. The technology is here, so that is what you just kind of saw. So with that, I'm getting shooed, so I'm also going over. So as I said, basically all this stuff is free. So Graphistry, you can get a free hub account. GPU Cypher, just pip install it. If you have a GPU or CPU, have fun. If Graphistry server happens to run it for you if you like it. In Louis desktop, we're not GA, we don't do, we're not doing it as a public GA. Instead, we're doing it in cohorts. And so, sign up, tell us a little bit about what your use case. We're looking for operational users. And so if you actually run investigations, we're prioritizing you and looking for folks to have fun with. And then also remember the bots bench, so check that out. If you're more on the AI maker side, I'd love to talk to you about making that better. So yeah, thank you.
Any questions? Can you talk about the cost of the tokens?
Yeah, so Victor's asking the cost of the tokens. Yeah, so this has been really wonderful. So remember I said last year we were about 2 to 3 minutes. It was actually one of the things we did last year was actually do multiple tries. So we'd actually do parallel tries, so it was really expensive. We are now a median of 1 minute. So 1/3 of the cost, and things are getting better. And then the other part that I should say, especially for our regulated industry users, we're starting to play with self-hosting models. And so that's, you might have noticed my questions earlier today. So that's also for, yeah. Any more? Cool. Well, all right. Hopefully that was interesting to folks and some fun free toys to play with. So thank you.